Okay, everyone, this is translating trig graphs. We won't be doing any period changings today, but that'll be in the next video. You see what I have written down, so hit pause, copy it, and then I will give you an explanation. So this is the generic form of a trig graph. So, like y equals mx plus b is a form of a line, y equals ax squared plus bx plus c is the form of a parabola. This is the form of a trig graph, and it could be sine or cosine. I just wrote it as sine. Absolute value is the amplitude. Remember, amplitude is never negative. If a is negative, it's a reflection. 2 pi over b is the period, sometimes 360. C, what's inside the parentheses, tells you right left, just like it does with h and k. So this is a right-left shift. It's called a phase shift, and it's going to tell us our starting point, which I'll explain in a minute. And D is the up-down shift. In trigonometry, though, it has a special name, and that is the sinusoidal axis. It sounds like you have a cold. Sinusoidal axis. So we're going to go through and we're going to label A, B, C, which way does it shift, is it up, down, is it right, left, etc. So notice that here it says plus D and the addition comes after. Well, commutative property of addition doesn't matter where the D is, it could be in the front. Generally, you're going to see it written in the front. So in this case, D is 2, which means that this is a shift up 2, and that is the sinusoidal axis. Even if it's a cosine curve, we call it sinusoidal. So the sinusoidal axis is at the sine of theta equals 2. Yes, you need to write it as an equation of a line. 3 is the coefficient on sine, so this is an amplitude of 3. B is 1. There's no coefficient. There is. It's 1. So if B is 1, therefore the period is 2 pi over 1, which is 2 pi. But you notice here I'm in degrees. So if my shift is in degrees, then I'm going to want my period in degrees. So the period is going to be 360 over 1, which is 360. I think it's helpful now if you determine what your intervals are, always divide by 4. There are 4 quadrants in the unit circle. So if the period is 360, each increment is going to be 90. And that matters because it matters on how I'm going to label my graph. And then what value of theta makes this 0? The answer to that is positive 60. So this is a shift right 60 degrees, and this is going to be where I start. Okay. It doesn't matter where you start in terms of how you draw the graph. I usually start with the sinusoidal axis. The sinusoidal axis is 2. So I'm going to go up 2. You need to draw it in. You must draw in the sinusoidal axis. I will not give you credit. I won't give you full credit on your homework if you don't draw in the sinusoidal axis. Okay, so this is 2. The amplitude is 3. So normally we start on the x-axis and we go up 3 and down 3. Well, now I'm going to start from my sinusoidal axis and go up 3 and down 3. 1, 2, which gives me 5 and negative 1. Okay, so notice the height from negative 1 to 5, the amplitude, but sorry, the amplitude's half that. The height is 6. Half of 6 is 3, and that matches my amplitude. Okay, the period is 360. I have 90-degree intervals starting at 60 degrees. So whatever. Like, I'm not super picky. My graph is going to start at 60 degrees. It's a sine curve. So I'm going to draw some kind of sine curve that starts at 60. with 90-degree intervals. So 60 plus 90 is 150. I'm randomly putting the 150, like I'm not counting tick marks. What I care about is that between 60 and 150 is 90. Another 90 would be 240. Sorry, I'm good. This doesn't look good. I know I said it doesn't matter, but it should at least look somewhat good. Add 90, I believe you get 330. Is that right? You guys aren't here to correct me. 90 plus 60, sorry, 60 plus 90, plus 90, plus 90, plus 90. Okay, notice that from 60 to 420 is a period of 360 degrees. Excuse me. The period from the beginning of the curve to the end of the curve should be 60 degrees. I'm sorry, let's start over. From the beginning of the curve to the end of the curve should be 360. So here we go. Instead of starting on the x-axis, I'm starting on the sinusoidal axis. I'm going to go up to the high point, back to the axis, down to the low point, back to the axis. Oh, such a bad curve. Better than I would have drawn in class. And this is one cycle, one wave. And it would keep going on and on in both directions. So I would add another 90 and another 90. I would subtract 90, subtract, etc. And this is a graph of y equals 2 plus 3 sine theta minus 60. So if you need to, of course, hit pause. Okay, we're going to do another one. Hopefully that's not totally crooked. I'm sure it's crooked. Okay. I'm going to go through, I'm going to label everything. This is a reflection. Okay, so up 4. This is left pi over 3. B is 1. Therefore, the period. In the last problem, I did 360 over B because the shift was in degrees. Here the shift is in radians, so I want to stick to radians. So if B is 1, the period is 2 pi. This is a reflected cosine curve. So when I'm all said and done, a reflected cosine curve flipped over, and the period is 2 pi. So the length from here to here is 2 pi. It doesn't start at 0 necessarily. As a matter of fact, I'm going to go left pi over 3. So I'm going to take this cosine curve and I'm going to move it left pi over 3. My increments, 2 pi over 4, intervals, increments, whatever, are pi over 2. Okay, so I'm going to start by with my sinusoidal axis, up 4. 1, 2, 3, 4. Okay, and that's 4. The amplitude is 1. The amplitude is 1. So I'm going to go from my sinusoidal, I'm going to go up 1, and from my sinusoidal, I'm going to go down 1. So up 1 is going to be 5. Okay, I'm going to, I don't want to go just up 1 space on my graph paper because that's going to look really messy. So I'm just going to go up 1 and down 1. I know that's not exactly right in terms of spacing, but if I drew it really close, then my cosine curve would be really hard to see. I'm going to start left pi over 3. Now I'm going to make a suggestion to you because some of you guys are really bad with fractions. This is side note. On a number line, 1, 2, 3, 4, whatever. You start with 1 if the spacing here from 1 to 2 is 1, etc. So let's say I start at 10. 10, 20, 30, 40. If my first increment, if I start at 0 and my first increment is a third, my next increment is 2/3, 3/3, 4/3, etc. So that's what's going to happen with this. My intervals are pi over 2, but my shift is pi over 3. So I need a common denominator, and the common denominator is 6. One sixth, 2/6, 3/6, 2/6, 3/6, 4/6, and going the other direction, -1/6, -2/6, -3/6, on down the line, okay? I'm going to reduce those in a minute, and I'm going to throw the pi on there in a minute. So if I'm starting at left pi over 3, left pi over 3 is -2/6. If you reduce this, that's -1/3, and then throw a pi on it. So I'm going to start at negative pi over 3. Okay. From negative pi over 3 to the next space needs to be pi over 2, which is 3/6. So I'm at negative pi over 3, and I need to add 3/6 to that. 1, 2, 3. So my next increment is at pi over 6. Add pi over 2. So you've got, pi over 2 is 3/6. 1, 2, 3. 4/6. I'm going to reduce it in a minute. So essentially I'm adding 3/6 each time. 4 pi over 6 plus 3 over 6 is 7 pi over 6. Then 10 pi over 6. I think I have enough. I'll throw one on there just in case. 13 pi over 6. Okay, this is not acceptable. You must reduce. So 4 pi over 6 becomes 2 pi over 3. Seven pi over 6 is fine. 10 pi over 6 becomes 5 pi over 3. This is a reflected cosine curve. So I'm going to start at negative pi over 3, 3. I'm going to go up to the max, which is, no, sorry, that's wrong. I'm going to go to the axis. Then I'm going to go up to 2 pi over 3, back to 7 pi over 6, and down to 5 pi over 3. This graph is really messed up because I put the pi over 3 in a bad place. But I'm going to cheat. I'm just going to move negative pi over 3. Doesn't matter physically where it goes. I just moved it over because the graph looked really messed up. Okay. Next phase is to do more complicated period changes. Answers to the homework are going to be online.